Welcome all. Today we are going to discuss about equivalent mass in analytical principles. So, what is equivalent mass or equivalent weight? Equivalent mass or equivalent weight of an element is defined as a number which expresses the number of parts by mass of that element which combines with or displaces 1.008 parts by mass of hydrogen or 8 parts by mass of oxygen or 35.45 parts by mass of chlorine or 1 equivalent mass of any other element. Okay. So what is equivalent mass? Simply, it is defined as the number which expresses the number of parts by mass of that element which combines with one equivalent mass of any other element. Okay, it may be hydrogen or oxygen or chlorine or any other element. So we have to consider equivalent mass as the number by which it expresses the number of parts by mass of that element which combines with one equivalent mass of any other element. Whatever be the element, that is hydrogen, oxygen or chlorine, it must combine with one equivalent mass of that hydrogen or oxygen or chlorine. Okay, when we consider two elements, when two elements combine with each other, the mass ratio is simply the ratio of their equivalent mass. Okay, that is the mass ratio in which they do so, that is in which they combine will be equal to ratio of their equivalent mass. Then equivalent mass of any element is related to its atomic mass and valency by the equation equivalent mass of an element equal to atomic mass by valency. For example, in the case of aluminium, atomic mass equal to 27, which shows a valency of 3. Hence, the equivalent mass of aluminium equal to 27 divided by 3, that is 9. Okay, so if an element shows variable valency, so for example, copper, it shows valencies like Cu plus 1, Cu plus 2, that is cupric and cuprostate. Its different valencies will be associated with different values of equivalent mass. Okay, so for copper, atomic mass is equal to 63.54. In cuprostate, its valency is 1. Its equivalent mass is 63.54 divided by 1 equal to 63.54. Okay, in cupric state, valency is 2. Its equivalent mass is given by 63.54 divided by 2, that is 31.77. Okay, so then the next term is 1 gram equivalent mass or 1 gram equivalent or simply 1 equivalent of the substance. The quantity of a substance equal to its equivalent mass expressed in grams is called 1 gram equivalent mass or 1 gram equivalent or simply 1 equivalent of the substance. Okay, so 1 equivalent or 1 gram equivalent mass is simply the quantity of substance equal to its equivalent mass expressed in grams. Okay, then next is equivalent masses of different classes of compounds. The first class of compounds is acid. Equivalent mass of an acid. Equivalent mass of an acid is defined as the number of parts by mass of the acid which contains 1.008 parts by mass of replaceable hydrogen. Okay, so equivalent mass of an acid is the number of parts by mass of the acid which contains 1.008 parts by mass of replaceable hydrogen. So the number of replaceable or ionizable hydrogen atoms present per molecule of an acid is called its basicity. So equivalent mass of an acid is related to molecular mass by equivalent mass of an acid equal to molecular mass divided by basicity. In the case of HCl, hydrochloric acid, it is a monobasic acid. So its equivalent mass is equal to its molecular mass, that is 36.45 divided by its basicity, that is 1. 36.45 divided by 1 equal to 36.45. In the case of H2SO4, sulfuric acid, it is a dibasic acid because it contains two ionizable hydrogen atoms. So its equivalent mass is equal to 98 by 2. That is molecular mass divided by its basicity, that is equal to 49. Okay, then next is equivalent mass of a base. Equivalent mass of a base is defined as the number of parts by mass of the base which is required to neutralize one equivalent of an acid completely. Okay, so for base, it is defined as equivalent mass is defined as the number of parts by mass of the base which is required to neutralize one equivalent of an acid completely. Okay, the number of parts by mass of the base which is required to neutralize one equivalent of an acid completely or to react with one equivalent of hydrogen ions. Okay, so the number of hydrogen ions with which one molecule of a base reacts is called its acidity, often referred to as its acidity. Acidicity, often referred to as its acidity. It is also equal to the hydroxyl ions furnished by one molecule of a base in aqueous solution if it is a soluble metal hydroxide. Okay, so what is acidity or acidicity? The number of hydrogen ions with which one molecule of a base reacts. Okay, it is also equal to the number of hydroxyl ions furnished by one molecule of a base in aqueous solution if it is a soluble metal hydroxide. So the equation of equivalent mass of a base is given by, it is related to its molecular mass as equivalent mass is equal to molecular mass divided by acidity. In the case of NaOH, the number of hydroxyl ions furnished by one molecule of molecule of NaOH in aqueous solution is 1. So it is a monoacidic base. So its equivalent mass is given by molecular mass, that is 40 divided by acidity, that is 1. 40 divided by 1 equal to 40. In the case of CaOH twice, it is a diacidic base. So its equivalent mass is equal to molecular mass, that is 74 divided by acidity, that is 2. That is equal to 37. This is because there are two hydroxyl ions furnished by one molecule of CaOH twice in aqueous solution. So the acidity is 2. Okay. Then next is equivalent mass of a salt. Equivalent mass of a salt is defined as the number of parts by mass of the salt that is produced by the neutralization of one equivalent of an acid by a base. Consider the reaction NaOH plus HCl gives NaCl plus H2O. Here it is obvious that equivalent mass of NaCl is 58.45. Okay. So the equivalent mass of a salt is defined as the number of parts by mass of the salt that is produced by the neutralization of one equivalent of an acid by a base. Here we have to consider the neutralization reaction. This given example of NaOH, that is strong base with strong acid HCl, giving salt NaCl plus H2O. Okay, so the equivalent mass of NaCl is 58.45. The next is equivalent mass of an oxidizing agent. Here the equivalent mass is defined as the number of parts by mass of it which can furnish one equivalent of oxygen for oxidation or that which gets reduced with 1 mole of electrons. Okay, so for example, the oxidizing action of potassium permanganate in acid medium can be represented by the following hypothetical half reaction. Here 2KMnO4 plus 3H2SO4 gives K2SO4 plus 2MnSO4 plus 3H2O plus 5 oxygen. It is obvious from the equation that one equivalent of oxygen is effectively furnished by 316 divided by 10 equal to 31.6 gram of KMnO4. This is because when we see this reaction, there are 10 equivalent of oxygen produced from 316 gram of KMnO4. So, how can we calculate the equivalent mass of KMnO4? One equivalent oxygen is effectively furnished by 316, that is 316 gram divided by 10, that is equal to 31.6 gram of KMnO4. That is equivalent mass of KMnO4 is equal to 31.6. Okay. So, oxidizing action of KMnO4. KMnO4 plus 8H plus 5 electron gives Mn2 plus K plus 4H2O. That is the mass of KMnO4 gets reduced by 1 mole of electrons will be equal to 158 divided by 5. That is gram molecular mass divided by 5. This is because there are 5 electrons in the reaction given above. So we have to divide this gram molecular mass of KMnO4 by 5. Okay. So 158 divided by 5, that's equal to 31.6 gram. That is, equivalent mass of KMnO4 is 31.6. From this we can conclude that is the equivalent mass of an oxidant is equal to molecular mass divided by number of electrons gained per molecule. Okay. So in the above case, that is in this hypothetical half reaction, we can see that the oxidation number of Mn undergoes a decrease from +7 in KMnO4 to +2 in MnSO4. So there is a decrease of 5. So for two molecules of KMnO4 giving a decrease of 10 electron. Okay. So we can calculate this, that is equivalent mass of KMnO4 like 316 divided by 10. Okay. So this 10 is also equal to the number of electrons gained per one molecule of this KMnO4. Okay. That is given in the equation. So a relationship that connects the equivalent mass of an oxidant to its molecular mass is equivalent mass of an oxidant equal to molecular mass divided by decrease in oxidation number during the redox reaction. Okay. So in the above two cases we have seen this type of redox reaction and redox reaction and how to calculate the equivalent mass of an oxidant. Okay. The next is equivalent mass of a reducing agent. The equivalent mass of a reducing agent is defined as the number of parts per mass of it which can be oxidized by one equivalent of oxygen provided by an oxidant, or that which furnishes 1 mole of electrons for reduction. It can be illustrated in the following example. That is, reducing action of ferrous sulfate in acid medium can be represented by the following hypothetical half reaction. Okay. So when we see the hypothetical half reaction, for 2 equivalent of oxygen, it needed 2 FeSO4. So that is 303.7 gram. So for 1 equivalent of oxygen, we have 303.7 divided by 2, that is equal to 151.85 gram of FeSO4. This is the equivalent mass of FeSO4. So in the case of reducing action of FeSO4 in ionic half reaction, FeSO4 gives Fe3 plus SO4 2 minus plus electron. So it is obvious that mass of FeSO4 that furnishes 1 mole of electron for reduction will be equal to gram molecular mass by 1. That is equal to 151.85 divided by 1. That is equal to 151.85 gram. Here the number of electrons is 1. So we have to divide this gram molecular mass by 1. So equivalent mass of anhydrous FeSO4 is equal to 151.85. That is equivalent mass of a reductant. Here FeSO4 is the reductant. So we can conclude that equivalent mass of a reductant is equal to molecular mass divided by number of equal electrons furnished per molecule. Okay. Here a relationship that connects the equivalent mass of a reductant to its molecular mass is given by equivalent mass of a reductant equal to molecular mass divided by the increase in oxidation number during the redox reaction. Okay. In the above case, the oxidation number of Fe undergoes an increase from +2 to +3. That is an increase of 1. Hence, the equivalent mass of anhydrous FeSO4 equal to molecular mass divided by 1 equal to 151.85 divided by 1 equal to 151.85. This is similar to the oxidation case discussed about KMnO4. Okay. So that's all. Thank you.